So welcome to an exciting journey into the world of permutations. In this video, we'll unravel the mysteries of permutations, exploring their significance in mathematics. So let the journey begin. If A has n elements, how many different sequences, each of length r less than or equal to n, can be formed from A if repetition is allowed? So the first sequence can be arranged in n ways, second in n ways, and so on. And by the fundamental principle of counting, this is n multiplied r times, that is n raised to r. Now we need to remember the number of binary sequences of length n is 2 raised to n. So go to the first problem. Find the number of binary sequences of length n that contain an even number of ones. So we consider case 1 where a binary sequence of length n minus 1 has an even number of ones. Now what we do is we append 0 to it. So if we append 0 to it, what does it become? A binary sequence of length n that has an even number of ones. Case 2 is when a binary sequence of length n minus 1 has an odd number of ones, and we append 1 to it, so we get a binary sequence of length n which has an even number of ones. So both cases, in case 1 and 2, what do we need to find? The number of binary sequences of length n minus 1, which is 2 raised to n minus 1. Now what is a bit? A bit is either 0 or 1, and a byte is a sequence of 8 bits. So find the number of bytes. Now each byte contains 8 digits and each bit is 0 or 1. So number of bytes will be 2 into 2 into 2, 8 times, that is 2 raised to 8, which is 256. Find the number of bytes that begin with 11 and end with 11. The byte begins and ends with 11. So there are 4 open positions which can be filled in 2 raised to 4, which is 16 ways. Find the number of bytes that begin with 11 but do not end with 11. Now there are 6 open positions and these can be filled in 2 raised to 6, which is 64 ways. Find the number of bytes that begin with 11 and do not end with 11. So this will be 64 minus number of bytes that begin with 11 and end with 11. Because total number of bytes is number of bytes that begin with 11 and end with 11 plus number of bytes that begin with 11 and do not end with 11. So this will be 64. Number of bytes that begin with 11 and do not end with 11 is, we have already seen that an end with 11 is 16. So it is 64 minus 16, which is 48. Because number of bytes that begin with 11 is 64. Find the number of bytes that begin with 11 or end with 11. So number of bytes that begin with 11 or end with 11 will be number of bytes that begin with 11 plus number of bytes that end with 11 minus number of bytes that begin and end with 11. This is like A union B. It's A plus B minus A intersection B. So number of bytes that begin with 11 is 64, number of bytes that end with 11 is 64, and number of bytes that begin and end with 11 is 16. So your answer is 112. Now the next question goes something like this. A telegraph can transmit 2 different signals, a dot and a dash. What length of these symbols is needed to encode 26 letters of the English alphabet and the 10 digits 0 to 9? Now a signal of length k can be encoded in 2 raised to k ways. So a number of non-trivial sequences of length less than or equal to n can be either 2 or 2 squared or 2 cubed or 2 raised to n. So that will be, taking out the 2, you get 1 plus 2 plus 2 raised to n minus 1, which is, this is a GP. So first term is 1, common ratio is 2. So it is 2 into 2 raised to n minus 1 by 2 minus 1, which is 2 raised to n plus 1 minus 2. So what do you need to remember here? You need to find a sequence of length. How many sequences you can have? You can have a sequence of length 1, which is 2 raised to 1, 2 is 2 squared, and so on up to n, which is 2 raised to n. To encode 26 letters and 10 digits, we need at least 36 sequences. So we have 2 raised to n plus 1 minus 2 has to be greater than or equal to 36, because this is the number of sequences. But we need at least 36, 26 plus 10. So by trial and error, if we take the values of n, if n is greater than or equal to 5, this is satisfied. So the length of the symbols needed to encode 26 alphabets and 10 digits is at least 5. Next question, find the number of 3-digit even numbers with no repeated digits. For the number to be even, the units place has to be 0, 2, 4, 6 and 8. If the units digit is 0, then the 100th digit can be filled in 9 ways and the 10th digit in 8 ways. So in this case, what is the total number of ways? 9 into 8, which is 72 by the fundamental principle of counting. If the units digit is not 0, it can be filled in 4 ways because you have 2, 4, 6, 8. And the 100th place can be filled in 8 ways because the 100th place cannot be 0, and the 10th digit in 8 ways because 2 digits have gone. So the total number of ways is 4 into 8 into 8, which is 256. So either you can have the first option or the second option. So total number of ways is 256 plus 72, which is 328. The next question goes something like this. How many among the first 1 lakh positive integers contain exactly 1, 3, 1, 4 and 1, 5 in their decimal representation? Now the number 1 lakh does not contain 3, 4 or 5. So we look at 5-digit numbers because this is a 6-digit number. So the digit 3 can be in any of the 5 places. Similarly, the digit 4 can be in any of the 5 places, and so can the digits 5. So since the digits can be repeated, the other 2 digits can be filled in 7 ways because we have 5 digits. So total number of ways is 5 into 4 into 3 into 7 into 7. That is 2940. So the total number of coming to the next question, find the total number of positive integers that can be formed from the digits 1, 2, 3 and 4 if no digit is repeated. Now number of 1-digit number will be just 4 because it can be filled in 4 ways. Number of 2-digit numbers can be filled the first in 4 ways, second in 3 ways, so it is 12. Number of 3-digit numbers, first digit can be filled in 4 ways, second digit 3 ways, third digit 2 ways, so it is 4 into 3 into 2, which is 24. Again, number of 4-digit numbers will be first digit can be filled in 4 ways, second digit in 3 ways, third digit in 2 ways, fourth digit in 1 way, so it is 4 into 3 into 2, which is 24. So your total number of ways will be 4 plus 12 plus 24 plus 24, which is 64. So that comes to the end of this journey. Thank you and stay tuned in for more.